and then you take over. Right.
Awesome. Hi, Neville.
Off to you, Neville.
Hello. Are we at 12 o'clock? Okay, good. All right, so I now need to share my screen, if I may. And to do that, I'm just going to share this window. So I'll start there. Okay, can you see my screen?
We can.
Yes.
Okay, so first of all, Inga has to be thanked for her persistent efforts in making this happen. And I'm very glad that we are doing this. The whole idea here is to provide a platform for a community of people who are interested in climate and health. And hopefully this will grow into something bigger. And I am promoting an idea which I'm calling REACH, which is called the Research Alliance for Climate and Health. And this stems from previous efforts to organize this group, and effectively the process within DFFE called the National Framework for Climate Services, in which different sectors are identified. And the idea is that there's a user interface platform that can inform the kind of work that SOARS does to provide climate services. And so I'm using this idea as a way of trying to break new ground. And so very conceptually, there's this idea of getting a group together, which would be anchored by the Medical Research Council, the Department of Health, NICD, and South African Weather Service, as the sort of institutional organizations that have the mandate, and then a whole lot of research entities to help us get more organized around climate and health. And that's all I'm going to say about that. This seminar series will be a part of that. And in relation to this, the other thing I want to say is that the Global Change Conference is happening at the end of January 2023, the last day of January and the first 2 days of February, and which is going to be in Bloemfontein. At that event, I'm hoping to host a side event or session on climate and health, and everyone who wants to contribute will be invited. And we will discuss, we'll have a panel, and we will discuss this idea of REACH and kind of, getting a mandate to proceed on that basis. So this is what I'm doing, and it's very much aligned with what Inga's initiatives are and others are thinking. And so I'm very glad that we have this opportunity to push this idea along, and hopefully it will grow into something more structured in the future. That's it. Thank you.
Okay, awesome. Thank you, Neville. It is, quite a growing and thriving community. The community that's interested in looking at the impacts of climate and health. So it's really great, Inga, to have really put together this seminar series. And I'm very glad to be able to introduce our first speakers. So Robert Maisha is going to be the one that would be presenting today. He's currently the lead scientist at the Weather Service, and his focus is more on data assimilation. So he's had more than a decade, about 14 years that he spent modeling, basically, so numerical weather modeling and prediction. He's also had a significant portions of time that he spent in academia, so associations with the universities like the University of Pretoria, UNISA, as well as the University of Limpopo, and also spent some time at the CSIR. His interest remained firmly in data assimilation, modeling, as well as looking at urban climate modeling studies. And then from an education perspective, he's currently a candidate for his PhD at the University of Pretoria, where he also completed his honors and master's degree in meteorology. The work that I'll be presenting has been with with contributions from Katelgo Ncognwane, who is also a lead scientist at the Weather Service. Her focus areas being specifically in climate and health. She's also got, long-term experience, more than 10 years that she's actually spent at the Weather Service. I actually met Katelgo in one of the meetings on the climate change and health network that was hosted in Pretoria. So we talked about a number of issues, but it was very interesting to have made her acquaintance at that point. So Katelgo, also from an education perspective, she's also currently involved in the completion of her PhD studies in physics with the University of KZN. So it's really great. We're looking forward to hear, what the Weather Service is currently doing in terms of weather and climate observations and how these may be used for health applications specifically. So please go ahead, Robert.
Okay, thank you, Sibusisiwe, and thank you everybody for joining in this series. For me, it's an honor to be here. I'm gonna put my presentation in slideshow. I hope you are all seeing it.
Yes, we can see it.
Yeah, I'm one of those who don't want to waste time, so I'm just gonna shoot, and then I'll see in the middle if Katelgo will want to do the last part. So she has to tell us now whether I should run through the whole presentation or should do the last part.
You can go ahead, Robert, and if I need to be answering any question, I will chip in, or I can do the last part. Is still fine. We'll see how it goes, depending on the number of slides that you have. I saw there are quite many, but yeah, let's see how we run through.
Okay,
Thank you, Robert.
Yeah, so the South African Weather Service, some of you may know, it's a regional center for weather and climate projection, of which we support the whole SADC region. And here we do numerical weather prediction, we've got seasonal forecast, and also we do climate projection. So the idea is for our forecaster, the forecast that you see every day on TV or you read on radio, it's coming from source. And then also we assist the farmers in agriculture and also the general public, aviation, all those centers we supply with the weather and climate output. So at source, operationally, we run the unified model. And then we do research with the WAF model and then the CCAR models. So for the operational ones, we run the UM with either with data assimilation and also without data assimilation. That is operationally. So at seasonal or climate timescales, we do all these predictions, and then we have got climate change group, we have got the health group, we have got hydrology, we have got energy, and we also have air quality group. So, but here I'll be talking about NWP and climate projection and their impacts on health. So the main model that we've been running for, I don't know how many years, but it's so many years, is the unified model that we run over SADC, meaning the entire Southern Africa. And then we nest it with the I'm gonna use a pointer. Where is my pointer? Yeah, I'm gonna use the pointer. So this is the whole entire SADC region, which also covers Madagascar and the islands around. And then we also run the high resolution 1.5 kilometer resolution model that covers only South Africa. So we initialized these models with the global input data from the UK Met Office. We run the model 4 times a day. 00Z, meaning for South African Standard Time, we add 2. So for 00, we add 2. For 06, we add 2, so that you get your forecast on time. And then we produce this forecast up to 24 hours, 72 hours ahead. And then we also run the model with data assimilation. This is set up over South African only domain at 4.5 kilometer. And then we run what we call a 3D VAR, and then we do that 3 hourly cycles. So this one will ingest stations data at any time, and then you also use satellites data. So, but this one currently we're running it twice a day, at 0 Zulu and 12 Zulu, and then we're producing forecasts up to 66 hours. So then we also have something what we call convective scale ensemble prediction system. So that is, it's an ensembles of models that we run at 4.4 kilometer over South African domain with 18 members. And there we're looking at a probabilistic rainfall forecast for 24 hours. And then also we use, I see that we use initial conditions and boundary conditions also from the UK Met Office. And we also run short range ensemble prediction system where this is run over SADC at 6 kilometer resolution. Here we apply different models. We have got our own source model, we have got the German model, and then we also use NCEP, and then we've got UK Met Office Global Atmosphere. So all these ensembles we use to do probabilistic rainfall. So for research, you might have seen a lot of papers. Here we used to run the WAF as a backup to the UM, where it's run at 4.4 kilometer over SADC, just like the unified model, and then we produce forecast up to 72 hours. So also for research, the one that we just introduced, the CCAM model, this is a similar system. We do NWP, we do climate projections, and then we also do urban scale. So then we do, we apply nudging. And then this one in future will be the system that will be able to support the climate change group and also the health projections. So you can see the observations network that we have. It's a dense network of about more than 228 automatic weather stations. And then this is what you use to feed into the DA system. And then the DA system, because it uses observation, we also use the UMETSAT data that some of the time you see the show on TV, the forecast also, or the satellite images that we have. So this one runs on 12 channels. This is the one that they updates when you are watching TV, they updates the forecast with, because this is, it's the satellite, it's a live tool for remote sensing. So every 15 minutes you get your images, and then that's how we support the forecast. So it has got so many of these parameters that we use from the satellites. Also, on a daily basis, you hear forecast that is going to be raining in this area. This is made possible by the 10 S-band radar that we have, the 2 mobile X-band radars and C-band radars. So this is available every 2 minutes, and then it covers the radius of up to 200 kilometers. So whenever the storm is coming from wherever direction, we are able to pick it up on time, and then we give warning. So those are the observation network tools that we use. There are so many of them that some of them I haven't mentioned, but yes, we have got global atmospheric watch, we have got units that looks at the climate data and all the stuff. So every day we produce our forecast, and then we put it up on our internal web page for the forecasters. That is where they get all the forecasts on a daily basis before they dissect this information and send it to radios and TV stations. So from the numerical weather prediction, I'm just going to run through the cases. So from source, when there is a serious event coming or an extreme event coming, like the tropical storm Eloise, immediately when we see that this is going to cause damage or it's going to grow into a tropical cyclone, then we are able to pick it up, and then the media release comes out to warn the people that this is going to happen. So in this case, this is an example of a media release. So once you have the media release, we want to see if the models are able to pick it up. So in this case, we run the unified model and then we produce forecast, the 24-hour forecast on this day. We want to check if it's able to pick up what is being observed. So here we run the UM at 4 kilometer, and then the WAF at 4 kilometer, the CCAM at 4 kilometer, and then we compare it with the GPM. This is satellite images information. And then we also grid the South African weather stations data to see if our systems are actually working, whether the numerical weather prediction models are able to reproduce what is being observed. So you can see, yes, they are being observed. The observed are being reproduced by the models. So then we say, yes, we are able to catch the system. So also on the 25th, this was when that Eloise made landfall. So on the 25th, you can also see that the pick up the system, the WAV pick it up, the CCAM, and then we compare with the GPM, and then we can also compare with the observed rainfall. So you can say the satellite, GPM, and the moles were in a very strong agreement with also with the observations. But always remember that our net observation network is not as dense as we wish to have. So the other one was the media release on the 12th or some few days from the 7th of April 2022. We all know about the catastrophic event that happened in KwaZulu-Natal. So then you can see on the left, that is the amount of rainfall that has been observed. So over KwaZulu-Natal, you can see more than 200 millimeters of rainfall were observed from the 8th of April up to the 11th. So we also use this scaling, the likelihood of and the impact. So whereby if the likelihood of the event is very high and the impact is very high, and then you can see the scale of 10. So this is what the forecasters use. So, and also on the right, that is when they release the media release. So we went back and ran the model. So in this case, we ran the model, the unified model. This is operational. 4 kilometer, and then we run the DA system 4 kilometer, and then because we also have the high resolution we run this one as 1.5 kilometers. And then we compare with the CCAM, in this case 9 kilometer, and then we also compare with the 3 kilometer, and then we also compare with the observation. So you can see that these models are able to capture the event very well. So that is how we disseminate all this information. So also on the 12th, we did repeat the experiment, and we see that yes, all these models are able to produce these events. And then when we also go very high resolution, that is when we get an advantage of using the NWP models. So some of the products that we show is once we run the model, we are able to tell you what kind of changes is going to happen in terms of temperature. When there is a negative temperature change, we know it's going to get cold. When it's positive, you can tell that, okay, it's going to be warmer by this much. So we are able to use those skills. I will explain more when we look at the health part. So in this case, when there is a fire danger index, the unified model also produce those indexes looking at various methods. So also the DA system does that, but some of the product with the DA, because it's a new system, we're still developing all these products for the public. So you can also see that when it's safe, we put the scale. The green one, moderate, danger, very dangerous, and extremely dangerous. So in most cases around October, November, when there is high fire danger index, we are able to warn the public on time. And then we also do ultra high resolution modeling. So this one on the left, we're using the CCAM at 1 kilometer resolution. This was a test case where we did the summer 2013. We want to see which areas have got urban heat islands, because they are very, very important in terms of health. You need to know when the urban health island intensity is more than 2 degrees Celsius or 4 degrees Celsius. You can see that this area is the municipality of eThekwini experience urban heat islands. So then we also use the unified model, that is some of my colleagues. We run this model at 333 meters. This is very, very high resolution, and you should remember this is very expensive. And then this case was run over Gauteng, or with the focus on OR Tambo. So we are able to tell which areas of Gauteng are prone to very high temperatures, and when in terms of seasonally and also on a daily time scale. So in this case, the health group can use this information to disseminate to the public. So I'm gonna go straight into the health impacts. So in this case, on the 5th of October, or some few days before, there was a media release that there will be a very strong heat wave over a few days over South Africa, and then this one covered very large spatial areas. So in this case, I'm going to show you from the 3rd of October, the maximum temperatures with the unified model, and then also with the data simulation models. You can see that the entire half, or the northern, from minus 28 degrees south, this area experienced very, very high temperatures. So this is on the 3rd, this is on the 4th, this is on the 5th, this is on the 6th, and then this is on the 7th, and then this is on the 8th. So just like we gave that media release. So then we said, okay, let's simulate this with different models. Then we ran the UM, and then we ran the UMD, we ran also the UM 1.5. Then we run the CCAM 9, CCAM 3, and then compare with the observation. So you can see that somewhere, remember here we are comparing apples to apples. So meaning we take the 4 kilometer and regraded it to 0.25, which is our observation network resolution. So you can see that the 9 kilometer models, sorry, the 9 kilometer and the 4 kilometer models, because this is a large scale event, they were able to pick it up. Whereas when we go high resolution, and sometimes the impact of the heat wave was a little bit minimized. So then we did also this on the 5th to see if they're able to pick it up. So you can see the dynamical movement of the heat wave. And I can tell you that at low-lying areas, the heat wave was more intense than in high-lying areas. But you can see also its impact over Gauteng and the entire western part of the country. So then we compare the DA with the 3 kilometers, DH4, 4.5, CCAM3, and then we find that, wow, they look the same. But when you look at the details, you can see that in some areas, yes, the model can reproduce one thing, but in some areas, they could be different. So that give us confidence that, okay, the model physics, the parameterization really works. And you should understand that at very high resolution, we normally switch off this parameterization. So you can see the 1.5 kilometer unified model also it's giving it's underestimating the magnitude of the heat wave, whereas the low resolution ones were able to catch the impact or the spatial distribution of the heat wave very well. So also, from our webpage for the health group, we put this discomfort index so that the health groups can use this information to disseminate it to the public. On the left, you have got your UM 4 kilometer on the right, and then we also show the data simulation one. So you can see that where is the high level of discomfort. You can see Limpopo over the low field, and also when you move to Mpumalanga, here on the low field. So then from the health group, this is what they do before they disseminate this information. They use the model output to derive something called a discomfort index forecast, whereby temperature is used and relative humidity, and then they apply their equations, and they can tell. I mean, if you look at the previous slide, you can see this area that is prone to high level of discomfort. Sorry. So you can see this area of Mpumalanga and northern parts of KwaZulu-Natal. So from this, they come up with indicators that when the temperature is less than 21, of course, you don't have to worry about the discomfort, but from 21 to 24 degrees. So it tells you that under 50% of the population feels discomfort. And then you go to higher categories. So when the temperature is above 32, then they call it a state of medical emergency. So that means all this information from the models, they are able to disseminate it to the community in time so that they are warned, and then you can take effective measures to protect yourself. So the other ones that you use, it's when you look at the heat stress climatology. Here we use station data and then calculate apparent temperatures. And then from then, they can be able to tell, like from 1979 to 2019, this is the climatology, probably about 40 years. And then they can actually categorize those index. So then you can see here that you take caution when the temperature, apparent temperature, is from 27 to 31, and then it tells you exactly how it impacts the community. And then you take extreme caution when it's between 32 and 38. So when the temperature is above 39 to 50, we all know that the normal body temperature of people is about 37.5. So when it's more than this, then probably you struggle to breathe, and then you get your heat strokes, and that is when you encounter a lot of fatalities. And from the modeling point of view, we look at who is mostly affected, and then I can assure you that everybody who is above 65 gets more impacted by these events. So here they do the combined heat wave impacts, and they look at the current climatology, the near future, and the far future climatology. So in this case, they use maximum temperature, heat wave duration, heat wave magnitude index, and then they look at the exposure to population, which means you look at the population density, the population, total population size, and the percentage of elderly and children. Like I said, when anybody who is above 65 gets more impacted, whereby you end up with fatalities because of heat stroke. So, and children less than, I think it's 2 or 3, less than 5 years, that is when the mothers, you make sure that when the child is asleep, you are very close, because you don't want them to you need to hydrate them all the time, and also the elderly. That is the time when also you don't want people out in the sun, because that's where the problem starts. So you can see during the current climatology where the level of this combined heat wave impacts is very, very high. You can see Limpopo on the western side and also on the eastern side. Basically, this is the low-fed area that is highly impacted, whereas when you get to when you get to the center of Limpopo, because of the elevation increase, then this impact gets reduced. So then they do projection for the near future climate. I mean, this is using RCP for 8.5 and 4.5. RCP 4.5 means you are mitigating the impacts of climate change, whereas RCP 8.5 means you are saying it's business as usual. You don't care about the greenhouse gases, you don't care about the number of cars on the roads. That is when your carbon dioxide starts increasing. So you can see into the near future that the western here, you got the hazard, the exposure, and then you have the combined impact. So you will see that the hazards are more into the future. When you get into the near future, the hazards are more into the eastern, and then who is more exposed, you can see the exposure, and then the combined impacts, you can see also the low-lying area, which is basically the low fed, that is the one that it gets more impacted. So here on the top, it's RCP 8.5 means you don't care about the impacts of climate, whereas RCP 4.5, you say, I'm going to do something about the climate and then reduce the greenhouse gases. So I'm looking at the business as usual. So when you go with the business as usual, you will see that the low fed to the west and to the east of Limpopo, it's mostly impacted when you look at the Limpopo province. So going into the far future, meaning the 2066 to 2095, towards the end of this century, you can see that the entire western part, where you have got all these power stations also, that they will be highly impacted by this heat wave impact. So, and you can see here with RCP 4.5, you're saying, although the carbon emissions are already into the atmosphere, you can see going into the far future that the impacts and then the hazards and the exposure still very high, but it's going to be reduced at some point in time. So in conclusion, I think we didn't waste a lot of time. In conclusion, we are saying that these models that we use to support the forecasters and climatology are very, very good too. And they assist everyone in decision making. It doesn't matter who you are. You know, climate change doesn't matter whether you've got money or you don't have money. So everybody gets impacted. So of course, these models, they apply fiscal parameterization schemes, and their benefits depends on the geographical location. And we know that when we go to very high resolution, we switch them off, and then we assume that the model is just running as it is, and then it's gonna reproduce the event realistically, because the high resolution, say 1 kilometer or 3 kilometers, very high, it's able to resolve the clouds at that grid scales. So yes, these high resolution models are able to reproduce the systems when you compare them to the observations. And yes, we are able to assist the health and application with various parameters that they want to use in health. And we are able to locate areas that are prone to heat waves. You'll see even high heat islands, and also where the level of discomfort is very high, and also the flooding area, we're able to pick them up on time and then disseminate all the information that the people want to use. And also, when we go ultra high resolution, we can assist with urban scale prediction of floods, because cities gets more impacted with floods, heat waves, strong winds, and also at the airport, that's where we want to mitigate the impacts of fog, especially when our flights are about to depart or land. So I think that is the end. I don't think I waste a lot of people's time. There is so much time for people to ask questions to me and Katelgo. So you can see we are available on Twitter, we are available on the Facebook, and then you can get your Weather Smart app. This is something that everybody should have if you care so much about the weather and climate and how it affects you on your daily life. And I thank you.
Awesome. Thank you so much, Robert. Before we jump onto questions, Katelgo, is there anything that you wanted to add, or should we just proceed with questions?
I think he's covered it. You can proceed. I will take any questions if they are there. Thank you, Civil Sister.
Okay, thank you. So please let's get those questions ready. I see, let me see, there's an option to raise a hand, yes. Also, if you want to pop some questions in the chat, you can do so. I'll try, between myself and Inga, we'll try to periodically check on that. What was intriguing for me, Robert, was the fact that, when you have, as you move to higher spatial resolution, you actually have a change in the spatial extent of your heat wave. And, as we try to develop heat and health models, the thinking is always that we should, get as high resolution as possible. Do you have any comments on, what have you found that maybe can inform us on what is the appropriate scale that would be useful, especially as we start thinking about developing models that connect your whether it's your heat indices, but that connect climate to health outcomes, because we're always pushing for higher resolution. But if there's a challenge in terms of it distorting the spatial coverage, so I was wondering whether you have any comment on what would be the optimal spatial scale for such applications.
Well, firstly, at low resolution, not very low, because we are using the CCAM is 9, the unified is 4.4. So what happened is at a scale of about 9 kilometer, 4 kilometers, we find that the physical parameterizations are basically switched on. So these models are scale away. So when you move from 4 to 1, we call it a gray zone. So that is the most interesting part to do the simulation. But somewhere at about 1 or 3 kilometers, when the parameterizations are switched off, yes, you at that very high resolution, you are able to simulate the event very well. But there are a lot of technicalities that we still need to improve the model. It's not that the model can pick it up. Remember, the models are not developed by us. They are developed somewhere. So you find that those parameterizations, they work very, very well in those areas where they are developed. So that is why in South Africa or in Africa, we should start developing our own parameterization or improve the parameterization, as you have seen. It doesn't mean the models are failing. At 1 kilometer, I've simulated the urban heat islands. Yes, you are able to pick it up, but you'll find that some of the parameters, some they get under forecast because the physics that has been used needs to be there need to be some adjustment. I think Neville will come in because that is where these people are responsible for model development should focus more on. So we also looking at it with some people from VETS and also UKZN. Thank you.
Okay, awesome. Do we have another question? Nothing on the chat.
Neville's hand is up.
I see there is a hand. Neville, yes, please go ahead.
Thanks very much. Thanks, Robert, for that very information that you shared with us. I have a question which I think I'm going to try to answer myself and then ask for comment on it. I guess the question is who determines what climate products you produce for the application in the health system and the health sector? And I asked the question as a leading question because what I'm interested to know is what are the health researchers requiring from the climate scientists? So what you showed, Robert, was a really nice wide variety of different kinds of products and various useful information that I'm sure can be applied. The question of resolution is an interesting one because certain health applications will require very high resolution and others not so high. And then there are lead times. Some will need lead times, as you described, of days at the weather scale and others at long term time scales. And then finally, there are obviously those climate events such as the ones you've described, those heat waves and the storm in UK and in KwaZulu-Natal, which are of direct health relevance because they kill people quite directly. But then, of course, there's a whole suite of medical conditions which are not immediate and are insidious, like changing averages, diurnal patterns of heat, infectious diseases, demographics of certain parasites, which are climate dependent, and so on and so forth. So I guess what I'm getting at is this idea that the community, what you're providing is really a sort of a repository of information, which I think needs to be refined in two directions. We need to know, as in, when I say we, I mean, let's say medical researchers need to know what we can get on the one hand, and then climate scientists need to know what they should produce on the other. And that's what we're trying to get to in the long term, I guess. And so for those that came late, that's why we are developing this idea of a research alliance in climate and health, and are going to hold a meeting about that in January, which you'll all hear about by email. Thanks. That's my question and comment.
Neville, maybe I can try and respond to your question on who informs our product development and the application. So in 2018, the South African Weather Service introduced a new division, which is called Socioeconomic Benefit Group. Those are social scientists that assist us in fact, they are the key in terms of the product development. They are the starters. So what they do, they actually conduct stakeholder engagements. It can be workshops, it can be through questionnaires, surveys, and that information is communicated back to us. And in the stakeholders, it's a variety of stakeholders, from academia, from the industry itself, and then that information is fed back into us, and then we develop our product. But not only that, government targets that are there in terms of, for example, DFFE, if they have certain targets that they're addressing as a country, we also chip in and we try and assist. Of late, you'll see that Robert has been communicating mainly on heat related. It has been something that is on the top of the agenda. So that is why most of the products that have been developed in the past 3 years have been solely, not only solely, but mainly on heat health. So we are informed by that, our engagements, and also even through just normal research that you conduct, and also through projects that we do. So it's just informed by different. And we send out, for example, also questions to find, because at the end of the day, this product must be user inspired. So we are targeting across the different climate sensitive sectors, including health, water, agriculture, and energy as well. So that will be all. And as part of that, because remember, Source is also has a leg of developing a commission or revenue from these products and services. So we also ask questions to say, are the tailor-made product that you want Source to conduct for you, and at what price you think you can buy those. So the SAB group really focus on that, getting that kind of information, which we will not normally get through our normal interaction channels. I'm not sure if there's any subsequent question that you want to ask from what I've just explained. You?
Thank you, Katelgo. Is there any further question, Neville? Okay. There is actually
I can
yes,
respond,
yes,
but
go ahead.
I'd rather give other people a chance to talk, and then if necessary, I will. Yeah, thanks.
Okay. There is actually a question from Albert. The question is, where can one obtain historical climate data specifically for research purposes? And I guess maybe to elucidate, what can be made available for research, as in researchers, students that are in at universities, and there are also other researchers that are sitting in other research institutes. So, Katelgo, Robert?
Well, so I can answer that one, or I can refer to one of my colleagues. I think there should be colleagues who are responsible for providing that climate data. I think there is Joe. There should be Joe or
Yes.
Lucky. I don't know who's available.
We are here. We do provide data for students for research purposes. But you do fill the disclosure document indicating that you want data for research purposes, which you are not paying for it.
Okay.
Thank you.
And is there a move to also look at researchers that are not necessarily students in academia?
Yeah, it will fall under a funded research where you pay a certain portion.
Okay.
Maybe also to chip in there, Sibusisiwe,
Mm-hmm.
if you are in a joint project with Source, then there are, of course, some less restrictions in terms of that. But again, we do follow Source policies to the T. But then if you are in a joint research, collaborative research with us, if you have signed some form of MOU, but then I need to say that some people tend to want to abuse that. But I'm putting these on the table just to be open in terms of what we're offering. But again, it's still going to be looked at by our climate department. But then if you are doing joint research, then then we can talk in terms of accessing this data. Thank you.
Awesome.
But again, the organization itself it's because we've had the plight. People are really they want to have access to the data, and we need it in order for us to address these many climate change impacts that we're facing. So there is that kind of let's say review that is happening, but not formally so. Please, it's a disclaimer. But then they are looking at trying to see what other options are there so that the data there's more access to it. Yeah, so there are those kind of talks that are taking place at the executive level, and hopefully in years to come, then we'll be able to have better options in terms of accessing this data. But there is something.
Okay.
Thanks.
Awesome. Albert, I saw your hand was up. Do you still have further questions?
Yeah, thank you very much. It's just a follow-up to the question I raised. Could you please provide information on probably whom to contact if one needs session, data? Maybe you can paste it in the chat so that I can do a follow-up. Thank you.
Yeah, Joe,
Okay, awesome.
can you paste it that email for climate data so they can send an email to?
Yeah, I was trying to type here, but I can't access I can't type here. But normally there are 3 people in the climate information desk. It's myself, Joe.Matsapula at Weather SA. There's Lucky.Dlamini at Weather SA.co.za. There is somebody can write because I can't access this and there is. Oh, I see somebody written Joel.Potai. No, it's not Joel. It's Joe.mat. JOE. The easiest one it will be Lucky.Dlamini at weathersa.co.za, joe.matsapola at weathersa.co.za, ntabisen.letsatsi at weathersa.co.za. I think these are 3 people that are dealing with specifically for public service requests. Then the commercial ones, but we do work together with the commercial ones. So, but if I give you these 3 names, then you can be able to access any of us at any given moment.
Okay. Can you maybe just repeat the last one? So we got Joe Matapola and
yeah, Lucky
we just and Lucky. We've got
and
Lucky.
Ntabiseng dot letsatsi. Ntabiseng. That's right. That is the right one. I think these are 3 people that can be able to help you, especially with the public service requests.
Okay, awesome. All right, thank you. Is there anybody that would like to come forward and ask your question? There is one on the chat, but I just want to give opportunity for someone to ask the question. Yes, Busisiwe.
Thank you so much. So I couldn't attend the first 30 minutes of the session. So maybe I might ask a question that has already been answered. What I wanted to know is does SA Weather actually look at the correlation between COVID-19 cases as well as weather? Like if it's cold, then you get increases in the COVID-19 cases. If it's hot, then there's decreases. Is there the type of research that you guys are currently busy with that's related to that? That's what I wanted to ask.
Yeah, I guess COVID and then also broader infectious diseases might be interesting. Yes.
Yes, yes, we are doing some research on that, but not particularly on cold per se. But then we've been looking at air quality and as well as UV impacts to COVID. But again, the research here can be expanded because we are looking at different weather parameters. So far, we have developed a air quality COVID product, which is championed by one of our lead scientists, Dr. Melaku. And it has been very instrumental last year in getting the information out there. Yeah, but again, to get back to you, Sibusisiwe, we do research on a wide spectrum of health related. Obviously, we are a very small group. One resource currently, Katelgo. So as we expand, then we'll be able to, do more research. But then for the past 3 years, it's been heat and malaria research. So we're working very closely with Neville as well. We also have a postdoc who's sitting at source. So we are looking at those, but then obviously there will be a specific focus at any given point, and we expand, particularly with our collaborative work with the IJUS, which Neville is heading, where we are looking at a number of those infectious diseases, including diarrhea and all that. But then the scope is not limited.
Okay, awesome.
Thanks.
Thank you. So Busisiwe, do you have a follow-up before I give opportunity to Neville?
Yes, please. So what I wanted to also ask is, since you've also mentioned other infectious diseases like malaria, are these published to certain platforms? Can they be accessed outside of the South African Weather Services? That's my first question. And then secondly, if a student or an institution is interested in doing a research that is COVID-19 focused with, say, weather services, how does that collaboration actually take place? What are the procedures and T's and C's basically to actually do something like that and publish it with South African Weather Services? Specifically for COVID-19. I'm more interested in COVID-19.
Specifically, I think, the last question, we can talk offline. I'll put my email address on the chat as well as Robert's email, and then we can have further discussions on that.
Thank you so much. I truly appreciate that.
And then I missed the first question you posed.
I was asking.
No, I think she was interested in just understanding the T's and C's around if she wishes to collaborate with SOURCE.
No, I think we can discuss offline with that. But then we have our professors like your Prof. Joel Batai, who's there. They're also supervising students and all that. So I think you will be assisted. And then we are working with a whole lot of universities, even the UP itself. So I'm sure that there's something we can arrange something. Thanks.
Okay, awesome. Neville?
Thanks. So I have to move off very soon. I just wanted to quickly say that Katelgo said a couple of very interesting things in her response earlier. One was that SOURCE needs to generate income from data, and this is very critical and subject of a study which I was involved in looking at funding models that will obviate the need for SOURCE to need to charge for data. And then the other was the means in which they that SOURCE gets its directive, and that's, I would like to argue that the need to really have a focused group which looks at the wide range of research that's taking place currently, and their specific needs for observations and or modeling outputs needs to be defined, and that's why we're promoting this idea of a research alliance around this. So yeah, So I think we've got a list of everyone that's here. There obviously are a lot more people who will of getting more organized in this particular sector, and maybe even demonstrate how it can be done, and that the relationship with climate services can grow accordingly. Thanks very much.
Awesome. We have time just for one more question before I let Inga wrap up and we close off.
There's Nada's question earlier.
Yes. So Nada's question is using world CLIM data, which is used mainly in species distribution models, appropriate for more local analyses, such as looking at a province within South Africa, or are there better suited data sets that are publicly available to model disease distributions? So Robert?
Sorry, I didn't get your question.
So it's around the use of world CLIM data, which from the question has been used more prolifically in species distribution models. So the question is, is there an alternative to world CLIM data, especially when you're looking at kind of like local analysis, so within provinces or even smaller areas, and you wish to model disease distributions? So just a comment on an alternative to world CLIM data that can be used, which is publicly available.
Sorry, I don't think I can answer that because I'm more of a numerical weather prediction and climate modeler. So maybe Katelgo or maybe Joe will be able to answer, or somebody who use climate data.
No, not from that particular platform. Maybe Nada, you can maybe chip in there if you have used that kind of data, not from my side.
Okay, cool. Just one last question, Robert. Because I mean, you use more the numerical models. I was wondering around the opportunities to use either more advanced statistical or even some of the newer machine learning approaches to maybe address some of the biases or shortcomings that you see in the current models that you have, as you remarked that there is this gray area where, due to the parameterization of the model, that there is a bit of a loss in skill. Can you comment on maybe opportunities for modeling, data-driven modeling specifically, that can aid in resolving some of that loss in skill?
Well, as for machine learning, I think when we talk of artificial intelligence, I think that is the route we want to follow, because the machines that we're going to use in future, they're using GPUs instead of CPUs. So I think we are on track with what they are doing globally, but we are willing to learn and follow suit. When it comes to statistical modeling, because we are more of dynamical modelers, our interest, it's not mostly on statistical post-processing or something like that. But in the past, we have used Kalman filtering system. So that kind of system, we use it operationally, just that I didn't show it. We use it operationally to do bias correction on the daily temperature forecast, because we have seen that with the Kalman filtering system, we are able to reduce a lot of bias. So going into the future, we want to use from Kalman filtering system at station level, we want to reproduce grid values that has been bias corrected. That is the data that we want to share with the modeling community. Bias corrected grid model output. Yes.
Awesome, Inga. You can take it away. Thank you very much, Katelgo, from my side, Katelgo and Robert. It's been very insightful.
Thank you, Sibu, for being such a great chair. Yes, That was a wonderful session. Thank you, everyone. And I really, really enjoyed also all the questions and discussions. I think that that's the point of having a seminar, to ask questions and discuss things. I have put, I hope you've all seen it, I've put a Google Forms link into the chat. We're going to have 2 more seminars this year. What the next one will be in 2 weeks' time on Wednesday, the 9th, also at 12 o'clock. But I think so that you don't miss it, I would prefer if everyone just fill in there so that I've got your email address and I'll automatically add you. I will advertise it again via LinkedIn and all of that, but in case you miss it, I think it's better if you fill in up the link there, and you can share the link with whoever you want as well. Obviously, you can decline if you don't want to come 1 week. But our speaker, next speaker in 2 weeks' time is Professor Cara D. Wright. I don't think I need to introduce her. I'm pretty sure at least 95% of the people in the meeting today know Cara D. So it will be an honor to have her speak for us in 2 weeks' time. And then further than that, if anyone else would also like to speak in our series, please just send me an email. We're really looking for people. We want to see what our capacity is, who's doing what, and really bring people together. So any talk that you have, or work that you've been working on, is very, very welcome. And it absolutely doesn't have to be finished research, or it could be ideas or anything. So students as well, if they would like to speak, that's also fine. So just send me an email if you like. My email is in the chat as well. And then please don't forget to fill in the Google link and share that. Okay, so we have people joining
Maybe
now.
a comment on the recordings. Would that be communicated?
If I wonder if people will be able to access it in the chat. Normally the recording goes there. Was that only for you in the meeting? Probably, hey. Okay, I will, if you would like the recording, if you can please just send me an email, because I don't have obviously everyone's email addresses. So if you would like the recording, I'll send a link to you. Otherwise, I'll send it to everyone who signs up in future as well. So it's 1:02. We'll chat again in 2 weeks' time. I hope to see everyone then again. Have a beautiful afternoon.
Thank you.
Thank you.